So imagine you've poured yourself just a steaming hot cup of coffee. So you've got steam coming out of here. And you know that it's pretty hot when you poured the coffee in, and it's going to start to cool. And the rate at which it cools depends on a couple of things. It depends on the initial temperature. So we're going to call T0 the initial temperature. And it also depends on the surrounding temperature. So if you take your cup of coffee outside in the winter, it's going to cool down much faster than if you just left it in your kitchen and let it cool down. So that means that the rate at which the temperature is changing depends on the temperature difference. So let me write this in terms of calculus notation. So the rate at which something is changing, and I'm talking about the temperature, the difference between the temperature and the temperature surrounding. This is the temperature of the object, and the surrounding temperature, Ts, depends on the initial, depends on the difference between the temperature and the surroundings. So the rate at which it's changing depends on the difference in the surrounding and the coffee or the material. So this is, actually it's not equal, it's proportional. So that means it's law of natural decay or growth. In this case it'll be decay because the temperature is going down. And the solution for this equation is so we're now going to use, I identified it as natural decay. We know the solution looks like this, and we're going to now solve it for a specific problem. So let's say you take you've boiled an egg, and you take it out of its water, and you know it's just boiled, so the initial temperature is 98 degrees. And then you cool it because you want to eat it. You know, it's too hot to touch, so you're going to cool it in some running water, and the running water is at 18 degrees Celsius. So the surrounding temperature for that egg while you're running it under the water is 18 degrees. And after 5 minutes, you measure the egg's temperature, and you found it to be 38 degrees Celsius, approximately body temperature. How much longer would it take if you kept running it under water? It'll get closer and closer to 18. How long would it take to get down to 20 degrees Celsius? So we are going to do this problem by using our solution to natural growth. We know that the surrounding temperature was 18. We know our initial temperature was 98. Surrounding temperature was 18, and we don't know what K is yet. So I'm just going to simplify this right-hand side. 98 minus 18 is 80. And I'm going to bring the 18 over. So I know that I've used basically this information. Now I'm going to use this. So after 5 minutes, the temperature was 38 degrees. So I'm going to plug in my temperature, which is 38, and my time, which is 5 minutes. And I'm going to solve this equation. So I'm going to bring the 18 over, subtract 18, and I get 20 equals 80 e to the 5k. Divide both sides by 80, so I get 2 over 8, which is a quarter. So I'm going to write this quickly as a quarter, equals e to the 5k. I take the natural log of both sides. You could write this as negative log 4, like we did with the last problem. And the natural log of e to the 5k. These two cancel because they're inverses of each other, so I have natural log of a quarter equals 5k. So that means k has to be the natural log of a quarter over 5. And I'm going to write this as negative log 4 over 5. So I know my equation now looks like this. It's got a t minus 18 equals 80. E to the k is this ugly number to the t. So here's my equation. And I'm going to use that now to figure out when I'm going to hit 20 degrees. So let me just scroll down to give myself a bit of room. I've still got my equation here, so I'm going to plug in 20 degrees. So 20 minus 18 equals 80 e to the negative log 4 over 5 times t. 20 minus 18 is 2. Divide by 80, which is 1 over 40. Take the natural log of both sides. And when I take the natural log of this, the e disappears and I end up with negative log 4 over 5 times t. And then multiplying my t, I'm going to multiply both sides by 5 and divide by negative log 4. And that, being very careful when you enter that into your calculator, you should get a time of 13.3 minutes, because remember our time is measured in minutes. So we've seen a couple of applications. Now it's your turn to practice using the practice questions.